Good evening, everyone, and welcome back to Hack Aura's 2025 speaker sessions. It's my privilege to introduce our next speaker, Anubhav Pandey, Data Science Manager at Mastercard's AI Garage. So, Anubhav leads a team of data scientists developing large scale AI and ML solutions for finance systems. Her expertise spans fraud detection, scalable modeling, recommender systems, generative AI, and fairness in AI, and also in critical areas that are shaping the future of finance. So, before MasterCard, she was a research scholar at IIT Madras, where she worked on diverse computer vision problems and authored about 100 publications in top tier venues. She also holds a 10 plus patent in AI for finance, making her one of the leading voices in the space. Today, as the part of Hack or a speaker session, she'll be sharing her insights on AI in finance, a session that will explore how cutting edge AI drives both innovation and trust in the finance world. So, please join me in welcoming Anubha Pandey. Yeah.
Thanks for the lovely introduction. So today I'll be talking about different applications that exist, different use cases, problem statement that exist in the space of payments, and then how AI is being utilized to solve those problem statements, right? But before I do that, since my introduction has already been given, I'll give you a background of where I come from, like what is Mastercard, and then you know what how is AI Garage positioned within Mastercard, just to give a context of what kind of work I do before presenting the problem statements and discussing about it and different AI solutions for it, right? So I think most of us use credit cards and debit cards also, right? When we open our bank, we mostly get the cards from the bank, and within that card, apart from your bank name, you also see logos of other companies, like example Mastercard, Visa, or RuPay, or Amex, right? So these companies, they are not like card providers, they are not like a card company. Instead, they are payment networks like Mastercard. So Mastercard is like a technology company that enables payment, that enable transfer of funds, transfer of transaction across banks, right? So that's what Mastercard is about. The goal is to make payments safe, simple, and smart for everyone across the globe. And in order to make that happen, we at Mastercard delve into a lot of cutting edge technologies like blockchain and different AI ML tools and techniques that is there uh, to enable safe payments, smart and simple payments, right? So that's about Mastercard. Now talking about how is AI Garage positioned in the whole picture of Mastercard. So at AI Garage, we focus on supporting all the fraud and risk related products of Mastercard. So, like I said, it's payment space. So there are a lot of fraud and risk that is associated with transactions, right? So our job at AI Garage is to safeguard our payments. So any risk that is involved, we try to mitigate them, identify them, right, and support our existing products. And if we see gaps in the existing product, we also propose newer products in AI Garage. So AI Garage is a R&D unit of Mastercard that supports fraud and risk products of Mastercard, right? And in order to do that, we do a lot of research in the back end. Like we publish a lot of papers, we file a lot of patents, we also take part in a lot of competition, so that we are at top of all the latest advancement that is going on in the industry, so that we can provide enhanced solutions that are more robust, that are more precise, accurate, right? And then we also collaborate with a lot of leading premier institutes. We collaborate with the professors to do these kind of research, right? So that's about AI Garage. Now, I'll be talking about different problems that exist in the payment space and how we use AI to solve them, right? So, but to understand different problems, it's important to understand how the payment process looks like, right? So, here is an example of how payment actually flows through different entities that are involved in a transaction. And once we understand this, I'll talk about different risk and fraud that might be associated, right? So whenever, as a card holder, I go to a merchant through either like in store, I physically go to the store and make purchase, or I visit the e-commerce website and then feed in my card details to buy certain goods, right? So in either of the cases, I'm presenting my cards to the merchant, and I am requesting the merchant to initiate the transaction so that I can buy the goods in return, right? So when this happens, merchants through its bank, which is called as acquirer. So there are banks involved, obviously, because the fund gets transferred between the bank accounts. So the bank of cardholder is called issuer, and the bank of merchant is called as acquirer. So merchant through its bank tries to identify the bank of cardholder, right? And this identification or routing of accounts, that happens through payment network, which is where Mastercard comes into the picture, and or any other payment network provider comes into the picture. So they help routing the signal from the acquirer bank. They identify the issuer bank, which is the bank of the card holder, and they help route the transaction. So once that happened, the request goes to the issuer through acquirer. The request goes of transferring the fund, and the request goes to the issuer, and the issuer has to decide whether they want to approve or decline a transaction. Looking at, if they seem risky to them, then they would probably decline it, stuff like that, right? So once they decide to go ahead with the payment, that is to approve the transaction, then comes clearing stage, which is when the transaction records get transferred between the two banks, and then finally the settlement happens, which is like actual fund gets transferred. So there are like a lot of steps involved in this whole process, but when you actually make the payment, it takes fraction of seconds, right? So it's like there are a lot of entities involved, there are a lot of communication, transfer of signal happening across these entities, while making sure that you don't make a fraudulent transaction, or a like seemingly risky transaction occurs in the network. So a lot of processes or a lot of products get activated in the backend that tries to identify or analyze the whole request thing of a transaction, and help issuer take a call on whether they should approve it or decline it. Because if they approve a transaction, it was fraudulent, then it's the bank who has to take the liability of fraudulent transaction, right? So and if they decline it, then the merchant has to pay the penalty of the transaction, because they are taking the services of all the entities that are involved. So for example, if they are using Mastercard service to route the payment, so Mastercard will charge them something, and if that gets declined, that amount goes into waste, right? So whatever happens, whatever decision is being taken, if there is risky transaction, then there is someone in the whole ecosystem who has to pay the price of it, and that affects the uh, the experience, right? So it's Mastercard's responsibility, or any entity in the network, but here we are talking from the Mastercard or payment network perspective. So it's our responsibility to make sure that this transaction is seamless, it's frictionless, and we prevent any malicious activity in the network, to safeguard all our customers, which is entity that are involved in the payment process. So that's the background of the payment space that I'm coming from, and I'll be talking about different problem statement that exist in this space, and how AI is being used to solve these problems, right? So like I said, it's Mastercard and therefore AI Garage's job is to support products that deals with fraudulent activity or risky behavior of any entities in the network. So the risk can be at the transaction level. So if the transaction request was raised, the transaction could be fraudulent, right? So one product is called Decision Intelligence Pro of Mastercard, which helps issuer takes a decision on whether they should approve or decline a transaction based on if it looks fraudulent to them or not, right? Similarly, there's account risk. Account, by account I mean credit card holder. They have their account at the issuer bank, so it's the account that refers to credit card holder, and there are different risks associated with that account as well. So either the credit card, I mean the person who is making payment through credit card, either the person is fraudulent. So there's a usual behavior of a credit card holder, right? And if the card gets stolen or any compromise happen at the card holder, the behavior would fluctuate. So so then the account gets compromised. So there's a risk associated here. And if a risky transaction is being requested in the ecosystem, then it's going to affect some or the other party involved in the payment, right? So the a risk that is associated with the account. Then there are risks that can be associated with merchant. Either merchant can be fraudulent or merchant is compromised. So there are merchants like ghost merchants which are in the system for like some days, like for a quarter or even lesser, and they only come active because they want to do fraudulent activity. They do that and then they vanish. So they attrite from the system, right? So then the impact of those fraudulent activity has to be bear by the bank that is associated with the merchant, which is acquirer bank, right? So here our objective is to identify if the merchant was risky, or sometimes merchant can also get compromised. So for example, there was a case that came out in 2021 from India, and I think most of you would be able to recall it. It was from Domino's, okay? And the news was that Domino's account got hacked, and a lot of information got leaked, and about like 1 million of cards got leaked by fraudsters through Domino's data logs. And apart from card information, their phone numbers probably, and order history, order logs, employee information, everything got leaked. So here Domino's is not fraudulent, but Domino's got compromised, right? So the interface got compromised and a lot of information got leaked. So here, this is again a kind of risk here that we also want to mitigate in this whole ecosystem. So apart from these entity level risk, there's bank level risk as well. So sometimes when merchant raise a request for example, you have Netflix subscription, right? And you provided account detail to get your payment deducted every month, for example. And then later on you discontinued your account. I mean, your account was closed, but merchant doesn't know that, right? And you did not unsubscribe yourself. So the merchant would keep on requesting because it is recurring payment. So every month you will get the amount gets deducted if the account is active. But if the account is not active and merchant is not aware of it, they would raise the request, but the request would get declined because the account doesn't exist. Now here, who is the one who has to pay the fee? Because they have been using all the services in the ecosystem. They would have used acquirers services, then payment network services and everything, right? And only to know that the transaction will get declined, right? So there's a service called account status inquiry through issuer bank, and that helps acquirer or merchants to identify whether the account is active or not. So sometimes instead of just raising the request and getting the declined transaction, paying the fine for it or paying the penalty for it, it's good to raise the inquiry. So this product help them identify when you should retry, right? So for example, it may happen that currently the account doesn't have money and therefore the transaction got declined. Probably in some time it would have money. So we do a lot of forecasting over here and help merchant identify like an optimal time when they should raise for payment request. So things like that. So that's how we like safeguard all the entities that are involved in a payment ecosystem, and just to make sure that the transaction flows smoothly and there is none of the entity that has to pay the fine of any declined transaction or fraudulent transaction or any risky behavior, just to mitigate any risky behavior from the ecosystem. So these are different problem statement that exist, and we try to solve them through a lot of AI technology, advanced AI technologies, to make sure that we are able to capture them with a very high precision, and there are very less false positives in our decision, right? So I'll now be talking about a lot of different technologies that can be used in the payment space to support all these different uh, products or different use cases in the payment space. So the first technology that I'll be talking about is sequential modeling. Okay, so now that I know that as a card holder, I make payment in sequence at multiple merchants, right? So okay, let's go here. So, for example, during weekend, I often go for shopping, correct? So I'll probably take a cab if I don't drive. Then I'll probably go to a cafe, buy coffee, do some shopping, have lunch, again do some more shopping, which is like probably grocery shopping towards the end, and then I'll take the cab back to my home. So that's my usual pattern that looks like over weekends. And over weekdays, similarly, I would have some uh, pattern for a particular kind of behavior, right? So now, and these patterns are pretty repetitive at a cardholder level. So now that I know that based on your sequences, I can predict something about your behavior as a cardholder at different instance of time. For example, over weekend, this is your behavior. Over weekday, it's your behavior. This is how your behavior looks like. Probably if you're a gamer, you would invest, or I mean, you would spend more on gaming industry kind of merchants. So there I can say something about your behavior. Probably you are making those purchases usually during evening or late night hours, things like that, right? So from those sequences of transactions that you're making, I can infer something about your behavior, and not just one cardholder, but for everyone in the ecosystem. And it is like a lot of cardholders would share their behavior, right? I mean, I can segregate cardholders based on these different behaviors that I have inferred through your sequence of transactions, right? So now that I can infer things from your behavior, I can probably also predict where you would be transacting next. And that is what sequential models helps us with, right? And if there is something anomalous or something off than your usual behavior, or the cardholder that shares similar behavior patterns with you, if you're spending on some category that is not your usual merchant or usual merchant of any other cardholder, probably something fishy is going on, and I would like to check with you once before allowing the payment, that is it correct that you have made the payment, right? Because our system says that probably this is off. So that's how we can prevent the fraudulent transaction. And if it wasn't fraudulent, then it would be like once you have feed in that, yeah, that was me, probably we'll update our system, update your behavior, and then again, based on future transaction, we will accordingly take a call on whether to approve or decline a transaction, right? So that's how sequential models can help us. And there are different technologies and different tools in sequential models as well, like Markov chain, which is more appropriate when your data is very sparse. Then there's TPP, where you can predict a lot of things about transaction, not just about where you're going to transact, but also when, and um, location, like different attributes you can predict through temporal point processes. Then there are recurrent neural network LSTMs that were there. And recently, like after transformers were introduced, people started using self attention module that helps us look at merchant level information as well, to make predictions. So there are different models that exist, different tools that exist in this space. And like I said, in the payment space, the use cases could be first fraud detection, because I know your usual behavior. Whenever you do something off, I can flag that and use that as signal in my model. So that cannot be the only signal that can help me identify fraud, but probably that could be an additional signal on top of my other signal that I use for fraud detection, right? Then I can also identify risk at merchant level. So, for example, if I know these are a set of merchants that are, for example, ghost merchant, they come into the system for like small duration of time and then they vanish. So now I have this set of merchants that are risky, that are ghost, and I can look at the sequence of transaction that has happened at these merchants. Then I can generalize and say, and like learn something about this category specifically, and anything that falls under this category in terms of the embedding that the network learns, I can flag them as risky as well. Then other application could be, like I said, I can predict next transaction because I know this is what the sequence of transaction you have been doing in the past. Now based on this, looks like probably you will be transacting next on this merchant. So again, from there we can do a lot of stuff, like we can help merchant, we can help especially like small merchants with what kind of traffic they can they can estimate for next month, next 3 months, things like that. So basically try to gauge how the traffic of cardholders at a particular merchant would look like, what kind of channels of payment they would prefer, and many more things can be inferred through these sequential models. Um, then comes graph, right? So now sequential models look at sequence of transaction at a cardholder level, right? But um, so for example, if my sequence has certain set of merchants from a category, for example, if I whenever I order food, I always do it from McDonald's, right? But there's Burger King as well, which is similar. But I have never transacted at Burger King. But other card holders that share similar behavior with me, they have transacted at Burger King. So it doesn't rule out my possibility of transacting at Burger King, okay? Because I always do it at McDonald's, let's say. But this kind of visibility I will not have if I look at for example, because that only does it for a cardholder level and doesn't look across cardholder or like across merchants. So maybe here I want to look at a bigger perspective. So graph can be helpful. So this is just an example of how a graph would look like. So the cardholders transact at merchants, right? So if I combine all the transaction of a particular region, then it will be a huge graph of card and merchant, and the edges representing the interaction, right? And then some of the cards can be fraudulent over here, some of the merchants can be fraudulent over here. So this is the holistic view I can have through graph, and then there are different tools or different algorithms in the graph that can help me solve different problem statement or different risk or fraud related problem statement that exist in the payment ecosystem. So for example, I have nodes which is merchant, either merchant or card here. I have edges which represent there was a transaction between these two nodes, okay? And yeah, so let's start with that. So node classification is, I for example, if I'm only looking at merchant node, I have this holistic view of the transaction in the form of graph. Now I want to classify based on all the interaction, which is based on all the edges that I see at this merchant. Is this merchant risky or not, right? So I can train a model. I can try to add features based on the graph, like degree, things like that. How many risky cards it is connected to. So I can do a lot of analysis, create a lot of data about the node, and then train a classifier, which can be graph neural network, or it could be a normal neural network or any other classifier, ML based classifier on these data. And I can train the model to predict whether the merchant is risky, right? So that I can do, or a card is risky, right? So with that, I can either solve risk at account level or I can solve risk at merchant level. But there are more problems in the payment space, like money laundering. So in money laundering, what happens is that you have a lot of accounts called mule accounts through which you pass transfer you segregate the money, and you pass smaller chunk through these mule accounts so that it doesn't get caught that a large amount of money is flowing in the network in a wrong way, right? So there are a lot of accounts that are associated here, across which that amount gets segregated, and they're doing money laundering over here. So basically there's a community that I need to identify that is doing some risky or fishy activity. So there are algorithms for community detection as well in graph that can be helpful for anti money laundering kind of solutions. Then like I said, link. There's another category called link prediction. So like I said, these edges here represents transaction. So if I predict this edge, this means I'm predicting whether a transaction would happen from this card at this merchant, right? So that kind of things I can do that can help me in fraud detection. So if the likelihood of a link is very low, then it means that the transaction was not supposed to happen with a very high probability. Probably there is something fishy going on here, but we are still not sure. So we'll use that as a feature along with other signals from the network that are indicative of fraud, and then we can train a model for link prediction over here, and that's what we can do, and that can be helpful in fraud detection. So that's how graphs are very helpful in the payment space to solve like a lot of problems, and also provide like a holistic view across card, across merchant, the kind of interaction that is happening. You can derive a lot of information from the graph and solve a lot of problem statements from through it, right? So these are different problem statements that can be solved through graph that I presented. Now I'm going to play a video. Okay, it's about how graphs are utilized in Mastercard to solve. Uh, Here, I think they're providing one particular use case. We'll go through it, how graphs are being useful here to solve common point of purchase, which is, like I said, merchant gets compromised and a lot of data gets leaked. Remember the Domino's example? So, for that kind of problem, how graphs are useful is what has been shown in the video. Uh, can you please confirm if you're able to listen to the audio? I'm just playing. Is it audible?
Yeah, it is audible.
Okay, I'll play it again. Okay.
On a Sunday evening in New York, Sarah purchases a Broadway musical ticket. Simultaneously, thousands of miles away in Singapore, Ethan grabs his Monday morning coffee. Seems disconnected, isn't it? But both bought an ebook from the same online merchant 24 hours ago. While they were asleep, many cards that transacted on that ebook merchant were being sold on the dark web. MasterCard's advanced algorithm identified the source of those cards to be that compromised merchant. This is made possible using graph neural networks. MasterCard analyzes billions of cards and merchants, forming a graph where edges represent transactions and nodes represent cards and merchants. This graph provides insights into fraud detection and risk prediction. For example, a merchant node may reveal if it's a potential ghost merchant engaged in fraudulent activities. Meanwhile, MasterCard ensures caution in Sarah and Ethan's future online purchases without causing discomfort in their in-person transactions. The MasterCard Graph Neural Network technology is a suite of solutions that form the foundation to a plethora of these AI-based products, such as decision intelligence for fraud detection and account intelligence for predicting card chargebacks. Using the latest technology to solve real-world business problems for our customers and clients. So you can enjoy your coffee or your favorite show at ease, while we protect your payments with the most innovative, AI-powered, cutting-edge technologies.
All right. So there was a keyword here called chargeback that I realized I didn't explain it before. That is related to account risk, which is a risk related to cardholder. So chargeback, it's actually a feature, or it's a actually a good feature that has been provided to support cardholders. So sometimes what happens is that by mistake transfer fund gets transferred to a merchant due to any reason, or for example, if the fund got transferred but the order was not placed, therefore you get the refund. So here this is like, by mistake the fund got transferred, and then afterwards cardholder could say that they didn't make the transaction, or it was by mistake happened, and therefore they want the money back, right? So what happens in this case is that issuer bank, that is your bank, cardholder's bank, the bank in which you as a cardholder have an account, so the bank refunds you the money and then later deals with the merchant to settle the amount. So here cardholder is out of the picture, right? But sometimes what happens is, if account is risky, we as cardholder is risky, and we are, you know uh, making negative use of this feature, so then for financial benefits, then it's a problem, right? So that is the chargeback related risk that we are talking about. So if at account level I have a lot of chargeback behavior, if it happens once or twice, it's fine, it seems genuine. But if I'm doing it very frequently, probably there is some risk associated and my intentions are not good here. So then it indicates risk, and that is what being referred to in this video. So that's another use case that we solve with respect to account risk in the payment space, and it's a big problem. um, all right, so this was about graphs in Mastercard. We talked about sequential model. We looked at a cardholder level, if I have sequence, what I can infer from it. Then if I want to look at the holistic view, so that I can also infer about the behavior of other similar card or other similar merchants, and then make informed decision about risk or fraud that is associated with the current transaction account or merchant, I can look at graph. Similarly, for community detection, if I solve for community detection, I can solve for anti-money laundering. Then the third type of technology that is also used in payment is generative AI. And these days, there's a lot of talks about how we can leverage them to solve different problem statements, right? So here is some high level example of how generative AI could be useful. It's not about how we use it in our products, but in general, how it could be useful. So one thing is that we can generate synthetic data, and how synthetic data could be useful. So in our fraud detection problem or use case, we see about like 0.1% of transactions are, or it varies across region, but that's a reference number for just to understand it. So for example, 0.1% of transaction is fraud, rest everything is non-fraud, right? So it's a very small percentage. Now to make the model learn about, so there's a huge class imbalance, and to contrast between fraud and non-fraud, it's very um, like model may not be able to contrast well because the representation of fraud is very low. So probably it won't be able to understand the fraud class as better as it can understand non-fraud class, right? So through synthetic data generation, we can generate more synthetic fraud data from our actual fraud data, and then we can balance out the classes and then train a model. So that is one thing that synthetic data generation can be helpful in fraud detection. Sometimes when we make a fraud detection system, right, and it's able to prevent or block fraudulent transactions, so we keep on improving our system because fraudsters are also evolving their techniques to breach our system. Now if I can generate frauds that probably I can expect in future, if I show my model those future forward looking frauds, then probably my model would be ready to handle any future fraud that might come. So if I can simulate that, I can simulate future looking fraud that can also safeguard my system, right? So against any future fraud, right? Then um, generative AI can also be helpful in providing intelligent customer support. So like you all know that there are a lot of chatbots at different platforms that you interact with whenever you have query at any platform with respect to any merchant. Nowadays all the chatbots are AI powered, so that is helpful in solving our queries. That's one. And even in payments also that can be helpful. The other application of this could be, so when we make a fraud detection system, right, and like I said, these fraud detection system help issuer take a call on whether they should approve or decline a transaction. So sometimes we have to explain our decision to issuers. For example, for a transaction, our system said that it doesn't look fraud, and then later it turned out to be fraud. So issuer would want to know that why in the first place you gave a very I mean, you said that it looks legitimate whether but it was fraudulent transaction. So in those scenarios we have to explain, and even if this is not the case, then our model should be explainable. It should be able to explain in clear with clear examples and with clear rules, like why certain decision was taken in the first place. So to explain those decisions, generative model can be useful because through generative model we can understand we can try LLMs could try to understand what class information was learned by our fraud detection system, and try to explain that in the natural language form so that it's understandable to users as well. And of course, personal financial recommendation is also there. Then third category of example, use case of generative AI could be advanced document processing. So here, uh, examples are like, we can extract payment information from invoice automatically and do some processing on top of it, or it can prevent or reduce manual data entry errors, and it can also streamline payment initiation process. So regarding the third example in this category about streamlining payment initiation process, there's a product of Mastercard that helps you through agent. It helps you uh, make a transaction, right? So there are a lot of so if there is like you have a pattern of transaction, then for some transaction you can reduce that redundant process, and instead an agent can help you make the transfer, right, so that it's easier for you through agent. So I'll be playing a video that explains how agent pays helps in processing the transaction. So I'll be playing the video for that.
AI agents are everywhere. Consumers are increasingly using AI to shop, book, and buy everything. But across the payment ecosystem, there's a big risk that payments are happening in the dark. No visibility, no personalization, no chain of trust. Mastercard Agent Pay changes that. We verify agents, tokenize every transaction, authenticate every step. And we standardize how agents and merchants connect, so nothing gets lost in translation. Consumer intent and consent? Captured and verified. Now, planning a birthday party doesn't require 20 open tabs. One prompt, and Agent Pay takes it from there, delivering smart, secure payments, powered by trust and visibility. Because life works better when payments simply work. That's innovation at the speed of life. Built for trust, designed for scale. Mastercard Agent Pay, powering the next frontier of commerce.
All right. So that was an example of, again, generative AI through multiple agents. You are, making payments where you don't have to do it manually, but agent would take care of it and reduce like a lot of redundant steps that we often don't like to do, right? Um, then the final kind of technology that is there in the payment space, there are a lot more, but I think these four are important ones that I wanted to capture in this session. This is the final technology that I wanted to cover. It's called responsible AI. So finance is it impacts a lot of users. So whenever you make transaction, everyone makes transaction online these days through their cards, through their bank accounts, right? Therefore it's very important. And like, if the AI is not responsible, if AI leaks your private information, if AI leaks your sensitive information, like what's your age, what race you belongs to, what's your gender, things like that, if they use that information to make decision, that is not good, right? So we also want to make sure that our AI agents or AI model that we build to solve different problems, they are also responsible. They preserve your privacy, and they don't use like demographic information to make any decisions, right? Because that's going to negatively impact a lot of users. So we look into like three use cases of three sorry not use cases, but three cases where um, we can look at the adverse impact of not having responsible AI models, right? So the first is Apple Card controversy that came around 2019, 2020. And the controversy was that Apple Card, that was underwritten by Goldman Sachs, allegedly it discriminated against women, and there were a lot of cases of such discrimination through Apple Card. But here I'm citing two important ones. So one was from a tech entrepreneur who reported that he got 20% higher credit limit than his wife despite his wife had a better credit score. Okay. And then another case is of was reported by Apple's co-founder that he had 10 times more credit limit than his wife. And in both the cases, they had joint finances, and their assets were also shared. So they both had similar financial background, despite the fact having similar financial background, the husbands were getting more credit limit on their credit cards as compared to their wife, just because of this difference in gender. So that is one case. The other is credit scoring discrimination. So whenever we apply for loan, right, we have to pay some interest on our EMIs. Through our EMIs, we pay interest on those loan, right? But the loan, I mean, the interest amount, it varies from person to person depending upon your credit score. So if your credit score is good, then probably you would have to pay lesser interest on that loan, and if it's bad, then probably the interest rate would be higher, and so on. Right. So here in this case, it was observed that in US mortgage data, it was seen that AI models that were trained on historical data, they shown racial discrimination patterns. So to some of the race, even though their credit history was good, credit score was good, their interest rates were higher because they belong to a particular race. So again, that shouldn't happen. Similarly, it was seen that if a business is led by or owned by a woman, probably they will have to pay higher penalties on their loans. So again, such kind of discrimination shouldn't happen just because you belong to a minority category or a demographic group, right? These decisions should purely be based on how your financial background looks like, right? So therefore, it's very important to have fair AI, and also privacy preserving AI. And the third case is payment fraud detection bias. So imagine, you just because you belong to a minority category or a particular section of society, you represent a particular section of society that is in minority. So just because of that, a lot of your transaction gets flagged as fraudulent and gets declined, and you face a lot of friction while making transactions. So that seems very unfair, right? So such kind, and there are a lot of other examples as well, but such examples shouldn't happen. And therefore we should make sure that whatever model we build, that is impacting and that is customer facing, impacting customers, right, those product shouldn't pick signals related to your demographic information, like your gender, your race, age, income, things like that, to take a call or take a decision and impact your life, right? So that shouldn't happen, and therefore responsible AI is very important. Now a lot of studies have been done so far uh, in this space, and initially people started looking into what are the cause of these discrimination. So they have seen that even though they don't provide such information to while training the model, still model tends to pick on those discriminatory patterns, right? And therefore a lot of studies were made to understand how this bias gets propagated even though you're not explicitly passing on such information to the model. And therefore different point of interventions were identified. First thing is that your data itself is very biased. So maybe in your data, for certain um, section of society, the representation is very low. And because the representation is low and it's not balanced across all the across all the groups, model tends to pick up on those bias because they are underrepresented. And hence, since they are underrepresented, Therefore, the model is also biased to them because they have not seen enough example of those kind while training. So when we train our model on such data, we need to make sure that we have equal representation of all the segments of the society, so that model doesn't pick up on those biases, right? The second is, while we're training the model, so the models are trained in a way that whatever the underlying task is, for example, if I have to detect fraud, so whatever the underlying task is, for example, fraud detection, then the model has to, like, improve the performance of fraud detection. So improve the precision with which you're flagging a transaction as fraudulent. So that is the only goal of the model, and therefore now it doesn't care about, in order to do so, in order to achieve that objective, am I picking up on the discriminatory pattern just so that I can improve the performance? Because there is underrepresentation in the data, and if there is an underrepresentation in data, I might just return discriminatory output, so that my performance is maximized. So, for example, if I know that only 1% of a particular category, um, for example, if there's a group in a society where a lot of transaction, 99% of transaction gets is fraudulent, only 1% is legitimate, I might rather just mark everything as fraudulent, and I can still achieve 99% accuracy. This is good, right? Same goes with the model. So in order to maximize the performance, they won't care about that 1% where they're not performing well. They would rather focus on this 99%. So to make sure model doesn't pick up on the discriminatory pattern, it's also important to introduce such penalties, such matrix, and therefore when you evaluate that there's discrimination, then you penalize the model while training it. And then finally, when you are consuming the output of the model, right? So for example, in fraud detection, if I go by, so the model outputs the probability of a transaction being fraud. So its probability, therefore, the values would be between 0 to 1. But since I know that only 0.01% of transaction is fraudulent, there's no point picking zero point 0.5 as my threshold, because I know that 50% of transactions are not fraudulent, right? So I can't pick zero point 0.5 as a threshold to determine whether a transaction is fraud or not. There I have to increase the threshold. Similarly, for different here in this case we were talking about fraud, but then for different demographic information also, uh, accordingly we should decide on the threshold, and there has to be human intervention here when we are actually deciding on consuming that output to uh, to provide to our end customer, so that we don't impact their life, because our model is discriminate because of the discrimination of our model, right? So these are different point of intervention where the bias gets propagated, and we have to be mindful of it. And a lot of studies have come up, a lot of papers are there that tries to mitigate bias at these different point of intervention, which is at the data pre-processing stage, which is called as pre-processing, then while training the model, which is in processing, and then after the model is trained, how you are using or consuming the output of the model, make to make sure that we are being fair here to all the section of the society. So that part is called as post processing, where again there are a lot of algorithms in these different spaces to mitigate bias from our output, from models output. I won't go into details of those solutions, because I just wanted to give you an idea of different things that are happening in the space of payment. um, so and at Mastercard we have been working on different algorithms. Probably I won't go into the detail of these algorithms, but like I said, at different stages we have couple of solutions that are proposed, of how we mitigate these biases from our model. And from different types of model, there are different types of algorithms that we use uh, to ensure that our models are fair. So I think that's all I have for today. Yeah. All right.
Yeah.
So if there are any questions, feel free to
Yeah.
ask.
Thank you, Anubha, for such a great session. And let's move towards the question. Okay. So, how do you see AI balancing innovation and trust in finance, especially like when it comes to sensitive areas like fraud detection and credit scoring? Like, how can people build their trust in this?
Um, So like I said that we have to be very mindful of how we are using the output of the model, right? So because there is underrepresentation, and we have to also accept the fact that because there has been historically there has been bias in our society, therefore our data sets are also biased, right? There are some sections that are underrepresented, there are some sections that are majority. So it's natural for model to pick up on those bias, but then it boils down to how we utilize those outcomes. So like I said, there are different techniques out there to make sure that the model is not biased. There are different evaluation matrix that are out there to evaluate our model if they are fair across all the for different groups in the society. Yeah, so I think, and then it again hampers some of the little bit of the performances as well. But I think it's more important to make sure that our models are fair than achieving x percentage of precision. But there are some work going on, like it's an active area of research. So there are some recent paper going on where they try to identify different causes of bias in the model, and while also addressing the bias, they make sure that the performance is also enhanced. So a lot of it's an active research area, and I think a lot of work is going on to make sure that models are fair and there's no discrimination.
Yeah, okay, got it. Yeah, also, so like when we are building large scale AI solutions like for global financial systems, so what is the biggest challenge that you face in scalability, and like how do you overcome them?
Right. So at Mastercard the scale is like we see 1 billion transactions per day, which is like twice the number of tweets that is there. So, and then for each transaction, especially in the fraud detection space, we have to take a call on like 50 milliseconds, right? So, to make sure that we are able to score all the transaction within that small fraction of time, we ensure that our models are not very heavy, right? Instead of making one unified model, we make several small models. I mean, so that we can get signals from each one of them that captures different behaviors. And then apart from models, we have also have like a lot of signals based on our domain understanding. We create a lot of features as well, and all these signals together, we train a separate model. And then we make so to answer your question, we make sure that our models are not very heavy, because if it's very heavy then it will take a lot of time. So we try to segregate the problem into smaller sub problems and solve them to get separately, and then combine them as a signal to our final model.
Yeah, okay. Okay. So,
Yes.
my next question is like, do you think AI will like fully automate certain finance function, or will humans oversight remain like critical in the future as well?
I think the space where, I mean, the industries that are consumer facing, like for Mastercard is not consumer facing. Our customers are banks, right? But industries that are consumer facing, I think they cannot afford to have like a fully automated system, because human intervention will always be required to make sure that everything is running correctly, and then they are not biased also. So a lot of evaluation needs to be done, and to make sure that we are, because if something goes wrong, it's the consumer who's going to get affected, right? So I think for those industry which is consumer facing, I think manual intervention will be required, if not forever, but for some time, for sure.
Yeah. Okay. Got it. So my last question is like for like young developers and hackers and also students here at Hackora, like what skill or mindset should they focus on to build like impactful AI solutions in finance?
Yeah, like I said that there's a lot of risk. So if I talk about this particular domain that I just presented,
Yeah.
I think they can think more about from a consumer perspective also, that when they make transaction, is there something that they ever thought probably if this can be solved, then it will be much easier for me to transact. Or whenever some inconvenience happen to them or to their nearby people while making a payment, maybe they can think of why that happened, and is there a way that can be solved so that the transaction, I mean, that's more frictionless and more seamless. So basically, I would say that from your own perspective, from your own experience, from your parents' experience, think about how, like, different experience that you have so far while making transaction. Was it I mean, was there any point when you thought probably this is something that has to be resolved, or this is something that is still a challenge that I face a lot, and can we do something to solve it? So from real experiences, I think we can make more impactful solution if you think more
Yeah.
about real experiences. Yeah.
Okay, noted. Yeah. Okay. Thank you, Anubha, like for such an enlightening session on AI in finance, and your insights into fraud detection, generative modeling, and like fairness in AI like gave us a clear view of how technology is reshaping the financial landscape. We are so honored to have you as a speaker and as a part of Hackora 2025. And to everyone who tuned in, stay with us because Hackora continues to bring more powerful talks from some of the brightest minds in AI and beyond. Thank you. Thank you so much for joining us.
Thanks, Ragini.